Problem number 6. What volume in milliliters of 500 molar NaOH is required to titrate 150 milliliters of 1.10 molar H2SO4 to the equivalence point? So two things I want you to remember before you do this problem. One is the definition of molarity, the capital M. And that thing means that many moles in 1 liter of the solution. So it's a measure of how much stuff, like salt, for example, you have in a liter of the solvent, which is usually water. So if you had like a 1 liter bucket of water with 1 mole of salt in it, then you'd have 1 molar NaCl. And the other thing is, acid-base theory. So what they're talking about when they say what mole of NaOH, which is a base, to titrate whatever amount of acid, H2SO4, what's happening here is that the acids donate H pluses, and the bases donate OH ions. And you see what's going to happen when these two combine. When you have H plus OH, it's going to form water. So what they mean by titrate it to the equivalence point is how much 0.500 NaOH is required to make all of the hydrogens from the H2SO4 turn into water. So that you no longer have an acidic solution, you're going to turn it to a water solution. So, okay, so we started with 150 milliliters of 1.1 molar H2SO4. So what does this mean exactly? Well, that means that we have 1.1 moles of H2SO4 per 1 liter. But we don't have a full liter of it. That's what they said in the problem. We have 150 milliliters of it, which is 0.15 liters. So what's going to happen here is the liters are going to cancel out, and you're going to be left with a certain number of moles of H2SO4. So we're trying to get a volume of NaOH. So we need to convert from moles of H2SO4 to moles of NaOH. Now you might think, so how to get, for every mole of H2SO4, how many moles of NaOH do we need? Well, you might think, well, we need the same amount of acid and base. So just 1 and 1. And that's technically true, but what you'll see here is that this H2SO4 has 2 hydrogens to give up. So it's going to be giving up 2 hydrogens into the solution, whereas the NaOH can only give 1 OH. So you need twice as much NaOH to keep up with the H2SO4, which is giving double the amount of hydrogen of the the base. So the moles of H2SO4 are going to cancel out here. So far we're up to moles of NaOH, which is a good start, but what they want is the volume. And they said, they told us that the solution of NaOH is 0.500 molar. So that means that in every 1 liter of NaOH, you're going to have 0.500 moles of NaOH. So this and this are going to cancel out once again, and you're going to be left with liters of NaOH, which is exactly what you wanted. So your calculation is 1.1 times 0.15 times 2 divided by 0.500. And you're going to get 0.66 liters, or 660 milliliters. I put it in milliliters because that's what all the answers were in on the test. So that's answer choice A on your test.